on the vertical axis against extension on the horizontal axis. So you now have to get a graph of weight. You mark the weight on the vertical, that is what they mean. This is the vertical axis weight, they are in Newton. The extension, have in mind we have converted the extensions now to 10 to the power minus 3. That means all of them now are in meters when you see 10 to the power minus 3. Now the highest, the values for the extensions, you can see 1 up to 5.3. And 5.3 is just slightly greater than 5. So it is 5.3 is between 5 and 6. There is no need for us to go to 6 because the extension did not. There is no need for us to go to 7 because the extension did not reach 7. The weight we have from 0 to 16. You can see from 0 here to 16. Let us now plot them as fast as possible. Plot in these figures. When the weight is 0, the extension is equal to 0. So when the weight is 0, the extension is 0. This is the point. We go. When the weight is 2, the extension is 1. When the weight is 2, the extension is 1. You can get them at this point. When the weight is 4, the extension is 1.7. When the weight is 4 here, we already have 4. 1 is here. 1.7 means we count 7 smaller boxes. 1, 2, 3, 4, 5, 6, 7. That is where you can get 1.7. When the weight is 6, the extension is 2.3. When it is 6, extension is 2.3. 2 is already at this point. So 0.3 means we add 3 smaller boxes. 1, 2, 3. That is where 2.3 is. After that, when it is 8, the extension is 2.9. When it is 8, the extension is 2.9. 2 is already here. 0.9 is 9 boxes. That will fall at this point. We proceed. When the weight is 10, the moment the weight is 10, extension is 3.5. When the weight is 10, the extension is 3.5. 3 is already at this point. 0.5 means we count 5 boxes. 1, 2, 3, 4, 5 at this point. We have 3 here, 3.1, 3.2, 3.3, 3.4, 3.5 is at this point. When the weight is 12, the extension is, the moment the weight is 12, the extension is 4.1. When it is 12 here, 4 is at this point. 0.1 is here. When the weight is 14, we have 4.7. When it is 14 here, 4 is here. From here, 4 is here. We only now need 7 boxes. 1, 2, 3, 4, 5, 6, 7 at this point. After that, when the weight is 16, extension is 5.3. When it is 16, we have 5 here. 0.3 will give us 1, 2, 3 at this point. The analysis, now I have joined the point with a straight line. I have just drawn a straight line to join the point, but one point was left out. That means you are not required to join all the points. What you do, you just look at majority of the points. You connect them. So majority of the point, we have 1, 2, 3, 4, 5, 6, 7, 8 of them. 1 is left out. So you can only draw a line that connects majority of the points. From that point, we now go ahead. We have got the answer here. But they said, the other question says we find the Young's modulus. If you can recall, I said the formula for Young's modulus E was KL0 divided by the area. That was the analysis we did for Young's modulus. We said KL0 divided by the area. Now, if that is the case, L0 is the original length. If you read the question, you can see it there. They are saying the table below shows the reading obtained when a wire of length 2.23, that is the original length, 2.23 in meters. We will not convert anything there. We now go to K. For us to get K we said is the same as the slope. We said the slope of the graph, the slope is the same as the force constant. So the slope is the same as the force constant. And here the graph is weight against extension. So if that is the case, formula for the slope is W2 minus W1 divided by E2 minus E1. No Y2 minus Y1 because the graph is W against E. So if that is the case, we can now go ahead to get the slope. In getting the slope here, we can just link them by a right angle triangle. I will take any 2 points and draw right angle triangle there. I have just taken 2 points on the line and link them now with a right angle triangle. If that is the case, W2 is the value at the top here. The value at the top here is 16. And W1 is the value corresponding here, which is 14. So that becomes the slope equals 16 minus 14. We will not come to the graph again in order to get E2. You can get E2 from the analysis we did here. Have in mind when W is 16, E will be 5.3. So this is 5.3 here minus. When it is 14, the extension is 4.7. This becomes 4.7. Have in mind all of them are multiplied by 10 to the power minus 3 because they are converted to meters. If that is the case, the extension becomes 16 minus, the constant becomes 16 minus 14 is 2. You have to divide that by, we have 5.3 minus 4.7, that will give us 0.6, multiplied by 10 to the power minus 3. Law of indices says, the moment we take the 10 to the power minus 3 up, it becomes positive. So when the power here goes up, it's 10 to the power positive 3. Divide that by 0.6. So the K, which is the first constant, is 2 divided by 0.6. That will give us 3.333. 3.333 times 10 to the power 3 Newton per meter. Again, we know the area. We have got K. We now need to get the area. The formula for the area we said last was pi d squared divided by 4. Now, according to the question, if you read the question, they are saying diameter of 0.71 millimeter. So the diameter D is 0.71 millimeters. Since it is in millimeter, we are going to divide by 1000. So when you divide this by 1000, you have 0.71 divided by 1000 will give us something like 0.00071 meters. Now, if you now substitute that into the formula for the area here, the area now becomes pi, which is 3.14 times the diameter. The diameter is 0.00071 all square. You have to divide that by 4. So when you substitute the values of this pi now is 3.14, we have d square, and d now is 0.0071. You square that, divide by 4. When you square 0.0071 all square, this is what you get. This is the value that you get. You multiply now that by 3.14 divided by 4, you get 3.96 times 10 to the power 3.96 times 10 to the power minus 5 meter square. That is the formula, the expression you can get for the area. Now, if that is the case, we can go ahead to get the Young's modulus. We already know that the Young's modulus is KL0 divided by A. Now, K, according to the calculations we did, K is 3.33 times 10 to the power 3 times the original length is 2.23 divided by the area. The area is 3.96 times 10 to the power minus 5. So what will happen here is we have 3.33 times 2.23 times 10 to the power 3 here times, now if 10 to the power minus 5 goes up, it becomes 10 to the power positive 5. You have to divide that by 3.96. So if I multiply that, I have 3.33 times 2.23, divide that by 3.96 will give us Young's modulus as 1.88 times 10 to the power. Law of indices, when the bases are the same, you take 1 and add the powers. 3 plus 5 becomes 8 Newton per meter square. That ends it.